In this video, we are going to get our basic game working. We're going to create what we need to in order to have our player move, our little cube, give it some physics, let it thrust up and around, and then hopefully go from one platform to the other, and then we'll go from there. So let's get started in an Unreal Engine. We'll go ahead and save because why not? One of the key tenets of an Unreal Engine, and I mentioned this before, was we have some things that come pre-built. So when I hit play here, you'll notice we have two platforms. Ooh, let's go and rename these. So let's figure out which one's which, shall we? So that's our starting platform. So this one's our start platform. And then that means this one's our end, or what we call that, goal platform. I'm not even doing the same naming conventions. That's hilarious. But we have stuff. So as we can see here, we have our starting and our ending. But when we hit play, we get an AI controller, another camera, which is super annoying, but we don't need it. Doesn't really matter. We're controlling this one. Our default pawn spawns in, some game modes, some player controllers, stuff we may not need, and stuff we do need. But it's all given to us from the base framework from our game mode. So we're going to create a new game mode, set up things we need, like a new player controller and things like that, and then remove things we don't need. So let's jump right into that. So let's do new blueprint. We're going to do game mode base. We're going to call this game mode, and this will call this Lander. Because we're actually going to create two game modes. One for the main menu, since we don't need a lot of extra stuff in the main menu, and then one for the game mode itself. Game mode itself, one for the game itself. We'll open up our game mode and we'll take a look. So game sessions. Don't need a game session. We're not really going to do anything in the game state, but we can't get rid of it. Player controller. We are going to make our own player controller. Player state. We can save things in there, but since we're not persisting things, not a big deal. HUD. We don't really need the HUD, but it is a convenient place to create the user interface, and we can get it from place to place, so I think we'll keep it. Default pawn. Well, we're not going to spawn in a default pawn. We're going to have it come in by our own self, and we're going to control it ourselves. So we'll get rid of that. And then there we go. Yeah, we're good here. So we got rid of what, two things we don't need. We're on a good start. The game mode's also where we're going to keep things like handling the game over, handling game start, things like that. Let's close our materials. We don't need those. We'll move our game mode over here because we'll need it in a second. And then we'll cover what we need. So player controller. Let's make a new player controller. Go back to new blueprint. Player controller, and we'll call this one player controller. And what, Lander probably? And this is where we're going to have all of our input. Our input's going to come through the controller, and we're going to tell our player what to do. Now, in order to use a player controller, we need to set it up. So we'll go here and tell it we want this player controller. And then we'll hit play, and we'll see if we have a problem. Well, we don't actually, if I can eject, there we go. We don't have that player controller. We still have all of our default stuff. If you'll notice, we have our default game mode, not our game mode Lander. Well, we need to set that up. Edit project settings, maps and modes, and this is actually a good time to change our default map. Change our game mode base to our game mode Lander. Good to go. We have all of our settings in here. Good to go. Oh, we're going to need to create a HUD. So let's go ahead and do that while we're here too. Blueprint class, all classes, type in HUD, and make a new HUD. And we'll call this one, let's see, HUD Lander, if I can spell properly. There we go. So now we have a HUD. Let's save everything because if something crashes, it sucks. We'll go back into here. Oh, let's see, game mode. Find our HUD, HUD Lander. We'll go and save, go back to our project settings. There we go. So now our default project is going to have our HUD Lander and our player controller Lander. So our custom ones. Startup map. Let's go ahead and change that to our game level for now. So that way when we start up the game or we start up the editor, we go into our game level. And that's it. Okay, cool. We're good here. And we're good there. And if we hit play, because I always like to double check and make sure everything's working, we should see, there we go. We have our GM Lander and our PC Lander. Cool. So now we can go ahead and use those. Now, all input is generally handled through your player controller, and it goes to your character, and then your character does stuff. Now, by default, you use a character, because most of the time you have standard movement. Even if it's something like a plane or a ship, you would use the character because it gives you things built in, network replication, stuff that's nice, but we don't need it for our simple project. Our simple project is going to basically fake input handling. We're going to pass in input to the controller. The controller is going to talk directly to our player and tell our player to do something. So let's go ahead and figure that one out. So the first thing, if you're coming from Unity, you may notice that you kind of have some problems if you're trying to do input. By default, if we were to go to our project settings, and then we go to input down here, this is where your input comes in. It's blank. Unity's nice. It gives you defaults for your up, your down, your left, your right, your different, your fire even. It has spacebar and left mouse button mapped to fire. It's nice and handy that way, but Unreal doesn't give you anything by default. We need to actually add it in. So let's go ahead and do that. We're going to go ahead and look through our input, and we're going to go ahead and create the input we need for our project. Now, there's two different input types. There's actions and axis. Action is press and release. Action, axis is pulled. Basically, every frame, it's going to check and see what the current axis is. If it's between 0, 1, 0, 10, whatever it is. Traditionally, you can think of that as like the joysticks, whereas the action is more like the buttons. Now, in our case, we're going to go ahead and we're going to use both. We're going to use both because we're going to run into some issues where we want to keep track of axis for things like if they have actually given any input this frame, so we want to reduce our thrust. And actions such as did they push the button, do we need to fire our particle or a sound effect. So action, we're going to make a new action called left thruster. And then we're going to map that to the left key. I'm going to map that to A because, wait, left thruster. No, left thruster is D. Never mind. Because when you fire the left thruster, you go to the right. And we want the people to push to the right to go to the right. Now you can do it the other way because that, oh man, that would be a hard mode. Switch the thrusters. So that way, if they push one direction, it actually fires the opposite thruster. So technically, you're pushing the buttons for the thrusters, but you're going the opposite direction because that's the way thrusters work. So, well, I would forget that and I would get so confused. So we're just going to go with something like that. And then bottom thruster. And this one will be the S key because it's on the bottom. Or is it the A key? Wait, we're going to go up. Okay, see, I'm already confusing myself. See what happens? Okay, so now we have 3 thrusters mapped. When we push these keys, these events we're going to fire off. And we're going to do some axis mappings. And this is going to be really simple. It's going to be up and right. And the reason we can do up and right is we have different input types. So if I go here and here, now up, for example, now these ones are easy. Up is going to be W. And down is going to be S. Find S. There we go. And it's -1. So that way, basically, when we push up, we get the up axis, and it's a 1.0. If we push down, we still fire off the up, but it's the negative axis. It's the negative axis, -1. There we go. So right, we're going to go D. And you'll find a lot of engines do stuff like this. It basically picks one axis, up, right, forward, for example. And that way, if you ever want the opposite, down, left, or backwards, you just get the negative value, or you multiply it by negative. That way you're not duplicating code. So there we go. There's our inputs. Something that's a lot easier in Unity because a lot of these come by default. We'll go ahead and close that up, and we'll see if we can actually get something working here. So we need our controller, and our controller is going to make stuff move. Now, like I mentioned earlier, we're basically going to take the input, and we're going to pass it over to our player, and then our player is going to do the input. So we have bottom thruster. Let's just start with the bottom thruster. Make it easy. So when someone pushes the bottom thruster, our player controller is going to get it, and something's going to happen. And then once something happens, something happens. Now we need to talk to our ship. We need blueprint to blueprint communication or variable communication or just some form of communication. You'll see how we handle this in Unity. We basically get the ship. So we're going to handle the same way in Unreal Engine. Again, lots of things are the same. In our begin play event, so whenever our controller is started, it's going to look for our ship. Now we have 2 ways of doing this. Normally, if you have a blueprint that's in our world, you could reference things publicly and you could pull them in or drag them in. Because the player controller is created at runtime, we can't do that, unfortunately. So we're going to get all actors, and try to spell it properly, of class. we're going to look for our player. So player. We're only going to have one player, so we'll just go ahead and get the first version, the first one, which is our player. And we're going to store this in a variable. And we'll call this player ship. Player ship. There we go. So all this does is grabs all of our players, grabs the first one, and saves it as a player ship. Now, if we ever need to talk to the player ship, we have a variable called player ship. So we'll grab this out, we'll get the player ship, and we're going to tell it to apply thrust. Let's do this a semi-smart programming way. Thrust is basically going to be the same. We're going to apply thrust. It's just going to be a different direction. So since we're going to apply thrust in just simply different directions, we're going to go ahead and make a function or an event or a method, if you're using Unity, for example, on the player. And then that player is simply going to take it in and do something with it. So let's find our player. So here's our player, and go to his event graph. And we'll save that out, and we'll make a custom event. So, oh my gosh, custom event. There we go. And we'll call this one, I don't know, activate thrust. Cool. Sounds good to me. We need to take it in a direction. We could do some fancy stuff. We could create custom ones in here. We'll just make this super duper simple. We'll take an input. We're going to call it direction. We're going to make this an integer. And we're just simply going to pass in an integer for the direction. So 0 will be down, well, bottom thruster, left. So we're going to go but down, left, right. 0, 1, and 2 is what we're going to do. Make things super simple on us. So we're going to need to go ahead and code that up here. So we're going to use physics to apply the thrust. So it should be pretty simple. How do we want to do this? Let's see. I'm looking through my other code because honestly, I completely forgot how I did this, which is really silly. What the hell? Seriously? How did I forget how to do this? Okay, damn it. Okay, so we're going to cut out most of this stuff. We're going to jump back to, where are we going to have jump back? We're going to jump back to where our, let's see, this is our player controller. This is the, yeah, and we want the axes is what we want. Add force is what we're going to want onto the ship. Okay. Okay, so we're going to jump back in. We're going to erase this stuff right here. Yep, and we're going to jump back in. Okay, so if you remember, I mentioned that we have different inputs. We have our action inputs, so when we press and release things, and then we have our access inputs. Now, our action inputs are going to be used for things where we want to toggle things on and off. Our access are going to be for things where we want to continually check, because every frame the access value is checked. For things like our thrusters, because we're going to want to basically apply thrust whenever we're holding the button down and let go of thrust when it's not, we're going to want to use our access inputs. So these inputs right here are going to be used for special effects. And then this one, for example, access event up, is going to be used for our thrust events. So we're going to grab this, and we're just simply going to add thrust. So the easiest way of doing that is to use something like an add force or an add impulse event to our object. So let's grab our ship. So let's find our ship right here. And we're going to add force. So we're going to add force to the player right here. Now, if you notice, we have two different things. We have the player ship, then we have the player itself in here. And if we go back to our player, it's because we have the ship itself, which is the entire blueprint, and then we have the player mesh, which is part of the blueprint. And we want to apply force to the mesh itself. So we'll go ahead and do that. Okay, and then we're going to want to simply add force. So let's just play with that and figure that out. Which way's up? Well, hopefully it's the Z direction. So we'll go and add, I don't know, let's try 10. Um, yeah, I don't know, let's see what happens. We'll hit play, and we'll push our keys, and nothing is happening. So we have an error. Let's see. You have to have simulate physics enabled. Well, yeah, that would be smart. We'll go back into our player itself. Here's our mesh. Simulate physics. We'll have to turn that on. We're going to run into some issues. We'll cover that here shortly. But basically, by default, nothing's going to happen. Remember I said we're going to simulate the moon, something with a lighter gravity? Well, that's where some of our issues are going to come into place. Our ship itself has a weight. If you look in here, you'll see it has a default mass. We have some dampening, so basically how much the ship moves or is affected by gravity, whether it has gravity enabled or not. So for example, if we disabled gravity and we used force, it's moving but barely. That's because we're barely giving it force based on how much it weighs, but there's no gravity, therefore it's going to go ahead and lift off. We need gravity though because we want gravity. So that's kind of where something important comes in. Where do we determine the actual gravity in the game itself? So we need to find that. So where are we hiding that one at? Well, that one should be in the world settings. World settings, and let's find our gravity. Override world gravity. Bam, there we go. Now, by default, if we set to 0.0, we might have a small bit of an issue here. We probably don't want that. We do want some sort of a gravity. Uh, by default, the world gravity is like 9.8 or something like that, 9.8 meters per second, or is it 980? Man, see, I can't remember. But we're going to go something like negative 300. So we're going to get a gravity pulling down. We'll hit play, and you'll notice that our ship fell back down. Cool. Let's go back into our player itself. Let's see. And we're going to have an issue with his weight. He weighs too much. So we can either adjust our gravity or we can adjust the weight. It's kind of, a 1-to-1 ratio. Let's adjust his weight. Let's set him something small. I don't know. Really small. Let's see. Let's see if we do something. Whoops. Why did that not type? There we go. Something like that. Let's make it weigh almost nothing. Let's see. Whoop. Okay, that might be a small issue there. We might not want to have such a small weight on him. Yeah, so let's figure out our next set up. Here we go, world settings. Let's see if we do, I think we did negative 300, which was not the right thing to do. God darn it. Okay, so now that you can see our ship is just flying off into space, we might be thinking to ourselves, well, we have an issue with our gravity and other settings like that. Well, no, it's not. It's got nothing to do with our gravity. Our gravity's set up fine. Our ship itself is actually set up fine. We have an issue with our input. Every time the up input axis event is fired, we are adding force. We're not actually checking to see if the player has pushed the up axis. We are just simply firing this event every single time. If we were to unhook this, for example, and check, you'll notice he falls down fine. So we need to make sure that this is firing when it's only needed. Now, axes basically rest at 0 unless you push a button. So we're going to go ahead and do something and check and see if we actually have any input. Now we could do something like equals, where's equals 0. And if it's equal to 0, we do nothing. If it's not equal to 0, we do something. So in this case, when I push the button, hey, look at that. We actually have a little bit of floaty gravity. One thing that's smarter, though, and you may have noticed when we were in here, is we type the equal. There is a nearly equal to node right here. Nearly equal is usually better to use because you could have some form of drift, especially if you're using a joystick. So we're going to go with nearly equal. Yeah, we'll give it something like 0.01, like that. So if it's almost 0 within this tolerance, it's going to go ahead and trigger off. So we'll go with that. So now we actually have movement. And you can see we have our little guy floating like we'd expect. Now he's got a little bit of gravity pulling him down, or we can use the up button to thrust him up. Cool, we have a good basic here. Now we should apply the same thing to our left and right, so let's go ahead and do that. And hopefully you can see how easy it is. So we'll do, let's see, we have what? No, we have right. So our axis event is right. We're going to go ahead and steal our code here, paste it in here like this, and this one is nearly equal to 0, false. Now, which way is left? Which way is right? Let's go ahead and look at our character again. Where's he hiding? There we go. So left and right is going to be on the y-axis. Positive y is right. Negative y is going to be left. So we'll see if we can wire that up. And you'll notice we kind of have a small issue here. We're only going to add one number to our y. So let's say we did something like 10. And we put this in. If I push right, we go that way. If I push left, we go that way. Well, that's kind of a small issue there. First of all, 10 is way too much, obviously. Our poor ship went flying off into the middle of nowhere. Second of all, we need to actually know how much force to add in which direction. We'll split this off. Now we have just simple values. We'll do 0 for z. And we're going to do it based on our axis value. Remember I mentioned, if we push right, we're going to get a positive. If we push left, we're going to get a negative. So if we apply positive or negative force directly like that, let's see what happens. Okay, we go to the right, and we go, if I push to the left, we go to the left. So we actually have a little bit of movement left and right. It's not very powerful, so let's try multiplying. Multiply by float. We'll multiply by something like a 1 to give us a little bit more force. We'll hit play. And now we get a little more control. There we go. Our character can float left and right. And you'll notice in theory, if we were to go over here and landed, crap, too far. We have, boom, our landed. Now you notice something, you may have noticed something on the land. And if we do this right, we'll notice something. Our ship falls over. We are allowing our ship to rotate when we don't want it to. So let's find our player. Let's find our static mesh. And let's find our, is it physics? Where is it at? It's in here somewhere. They always hide it from me. Collision? Seriously? We're looking to lock the rotation. And how is it that I can never find it when it's hiding from me like this? It's not in the player, right? I could swear it was under physics. Did I seriously lose it? Oh my gosh. Okay. Let's just type in lock. Nope. Okay, so it's not inside of our player. Not in our platform. It's not in the controller, is it? Can't be in the controller. Ah. Okay, I could swear it's in here somewhere. What did you guys do with it? Where did it go? Oh, constraints. Oh my gosh. I can't believe that was hiding from there. Lock rotation under constraints. Here, you know, I typed in lock and it didn't come up. That's kind of annoying. Constraints. So, whoa, constraint. Whoa. Okay. Why is my search? Okay, let's try something else here. Let's. Huh. Well, okay. That's an annoying bug. So lock rotation under constraints is what we're looking for. And that will basically prevent it from rotating. So if we're like here on our edge, you'll notice we don't rotate anymore. So that's what we're looking for. Other than that, I think we are pretty much done with the basics on the Unreal Engine side. It took a little bit of messing around, unfortunately, but we were able to do that. So let's go ahead and jump into our Unity side. Now in Unity, we're going to have to be doing most of the stuff inside of scripts. So this won't be too much of an issue, but it shouldn't be that bad. So we need to look at our player. Now our player has got, we've got our mesh and everything on our player. We could probably put the script directly onto it. So let's go ahead and add a component, and we'll do, oops, I typed in S. There we go, new script, C# script, and we're going to call this player because that's what it is. and we'll create a new player script. We'll go ahead and start up. We'll just start up. Open up Visual Studio, and Visual Studio should fire up. There we go. Silly thing. And we'll go ahead and start coding our player script. Now, our player script is basically going to control our player and control all of our stuff inside of that. But the first thing we want to do is get some form of movement working. So I'm going to clean this up first. So we actually have, I don't like braces being on different lines. We'll go ahead and save this, clean up the extra thing on the back, and now we are ready to code. Now for Unity, it uses inputs. If we were to go to our Unity itself right here, and we were to go to edit, if we were to go to edit after it finishes compiling, thank you, project settings input, we're going to find all of our default inputs. And you'll notice that it has some. Unlike Real Engine, we actually have inputs. And you can see horizontal, vertical, fire button, scrolling, things like that. We're going to have horizontal, vertical, which is going to be mapped to our left and right, which, let's see, alternate input, where's it at? Right here, A and D. And then we're going to have vertical, which is going to be our up and down. And the nice thing is we can actually check for the axis, and we can check and see if the buttons are down, all from the same thing inside of here. We just have two different codes inside of our input class. So we're going to go ahead and do the input axes for left and right and go ahead and give ourselves some movement. If we were to go into our code, so let's open up the script editor, we're going to want to put this probably inside of our fixed update. So let's do that, fixed, and we'll let it finish out. Fixed update is basically an update or begin play if you're in Unreal, not begin play, an update in Unreal Engine, except this is driven in the physics step. And because we're going to be adding physics and we want to kind of try to make sure this is frame rate independent, we're going to call it in our fixed update so that way it kind of sticks to a fixed pace. Okay, so input. This should be pretty easy. So we're going to do input.get axis, and we're going to check and see if we have something on the vertical. So vertical, we've already determined vertical is our up and down, or our W and S key. And we're going to check and see if it's something. So we're going to see if it's greater than 0.01F. Remember I said you don't really want to check and see 0. Give it a little bit of tolerance. And we're going to do something. Now, what we need to do is give it force. If we look at Unreal Engine, and as I said, a lot of stuff similar. We go to our controller. We're using the add force, and we're simply giving it force on the X or the Y or the Z. If we go back in here, well, we can do the same thing. We can look for add force. Now, add force is, that's kind of cool. I just copy pasted a blueprint inside of Unity. That was handy. Let's try that again. Now, add force is part of physics. Physics requires a rigid body inside of Unity. So that's something we're going to have to fix. So on our player, we need to add a rigid body component. So, boom, rigid body. Now we have a rigid body. Now we have mass, drag, using gravity. We have those extra things that we had inside of Unreal Engine, now inside of Unity. So, I got to stop hitting save. It's like my default. Let's save that map while we're here. Okay. So, my default, every time I do something, is to naturally, folder, hello, scenes, hit Control S, which is save, just so that way I actually have saved whenever I do something. It's instinct. It's a good habit to have too, by the way. So now we need rigid body. So we need to be able to get our rigid body, and we need to be able to add force to our rigid body. Now, with Unity, the nice thing is you can make like a public variable, and then you can go ahead and just add it in, and we're good. So public rigid body, rigid body. There used to be quick accessors in older versions of Unity, but they got rid of them. They're trying to standardize things. So we don't have that anymore. Add force, and then how much force we want to add. And we basically need to figure out. So which way is up inside of Unity is the better question of the day. Remember I said things are different? Well, let's find out. It's got to compile a script. We'll go ahead and look. So Y is going to be our up direction, and X is going to be our left and right. Now we can add straight to the Y, or we can kind of cheat because there are shortcuts inside of Unity. We know, remember I mentioned before we had up shortcut and right shortcut and forward shortcuts in Unreal. We have those in Unity as well. So we could do something like transform.up times, and then whatever value we want. And delete. There we go. And this is basically going to say, hey, add force on the up direction times 6. Now, in theory, this might work. This is the nice thing about this is we'll just drop back in and we'll hit play and see what happens. Our character should fall, hopefully, because gravity kicked in. And when we hit up, we have an issue. Variable rigid body of players not been assigned. Well, duh. That's because I didn't assign it because I'm a dumb head. So we'll go ahead and take our rigid body right here. Grab our rigid body. Drop it in. We're going to update our player. So our prefab's updated. We'll hit play again. Our character should drop. And we should have an up. Now, we don't have anything happening. So we need to figure out why. Now, is it actually working? I don't know. Let's find out. We'll go into here. We will F9 to give it a debug. Attach to Unity. Let it start up. Unity should fire up inside of the editor. Where'd it go? It's hiding from me. There we go. And we should be able to debug if that gets called. And there we go. It got called. Input get access vertical. We will step through this. And it looks like it did not get called. Oh, well, duh, it didn't get called because we're not holding it down. Yeah, see, this is not going to work very well here. Let's go back and let's debug on that line, shall we? There we go. And there we go. So it is. Vertical is getting done. Grab the rigid body on the player. Add force up times 6. Okay, so maybe we have some other issues here. Maybe we don't have enough force. Let's try something ridiculously silly because we can. And pause that. Play it out. We'll get the new one. We'll go ahead and hit up once it starts. And, oh, lordy, it went flying. We'll hit play again. We'll not hit anything this time. Okay, so our issue was we simply didn't have enough force. Now, my default project I have set up has got it set for 6. If you remember in Unreal, we had to change a few things. We have our default gravity level. We have how much weight everything weighs. So you have lots of different settings that we need to mess with. Because if we don't mess with them, obviously it's not going to work. So let's go ahead and look through that stuff. So we'll go through our engine itself right here. We'll look at our player. Here's our mesh render. Here's our rigid body. Okay, so we have no drag. We probably want to have some drag in here. So we'll go with 0.3. And then we'll go with an angular drag of, oh, why not 0.3? We have gravity enabled. Cool. We have a mass of 1. Okay, cool. Where's our gravity setting, though? Well, let's see if we can figure out where our gravity setting is. Project settings, physics. Ah, there's gravity. Negative 9.81. Well, that seems kind of familiar. Well, the reason negative 9.81 sounds familiar is because it was negative 980 by default in Unreal, because the default gravity on Earth is, whatever, negative 981 centimeters per second or meters. I don't know. I'm not a physics person. I barely understand it. But that's the right number for Earth gravity. Well, we're not on Earth. We're on the moon. So let's go with negative 3. Let's try this again. See what happens. We'll hit up. Oh, look at that. We have some floatiness. Look at that. We've got a nice little floating effect. I don't really know if my guy's falling well enough. What if we give him a little bit more weight? What happens if we do 2? So the nice thing is you can just play around. It's all visual, just like Unreal Engine. Unity is that. And up does nothing. So 1 is way too much weight. Our drag maybe we could give. So that way he falls a little more. And the nice thing is you can just play with this stuff. And of course, I edited it in the middle of editing, which means all those numbers meant nothing. Because you cannot normally edit and change values in the inspector and have them saved. There we go. Okay, so we're good. So there we go. Simple as that. We have some physics. We have some floating. Let's go ahead and apply that to the other directions. Hopefully it should be really simple to figure out here. Because we want multiple inputs to be accepted, well, we only need 2 of these. We want to be able to go, for example, up and to the right at the same time. We don't want to do an else if. We're just going to run both of these. So we'll do an if and an if. Again, it fires off during the same frame, so we'll get 2 different types of forces added. We'll go horizontal. And then we'll do that. Now, if horizontal is greater than 0.0 or less than, because we want to trigger left and right. So we'll copy, paste. We'll see if this is less than 0.0. So as long as it's not in that dead zone, we're going to do something. Hey, look, transform right will give us our right direction times 6. But we kind of need to make sure we have the actual input value. Now, get access gives us a float. So why don't we just steal that? We're going to do this times 6.0f times the get access horizontal. So if we're going right, we're going to get 1. If we're going left, we're going to get a -1. We're going to multiply it all because I like parentheses to make my math look better. We're going to take this and times it by a positive or negative. Let's see what happens. By instinct, because I'm used to the play button in Unreal, I always hit that button, and that's not what you want to test it with. There we go. Now come back, and yeah, we can go up. Oh, look, we can go right, and we can go left. Whee! Look at that. Now can we tip over? Oh, look at that. We still have the same issue. But what do you know? It's probably going to be really similar to fix like it was inside of Unreal Engine. So let's see if we can figure that out. Oh, look. Rigid bodies are physics. Oh, look. Constraints. Freeze rotation. Look at that. Knowledge carries back and forth between pretty much anything you are programming in. That is something that's very important to keep in mind. All of the work we did in Unreal Engine, 20 minutes or so worth of work, we were able to duplicate in like half the time in Unity simply because we were able to take knowledge that worked. We played in Unreal Engine, we figured out what worked, and then we just literally duplicated it in Unity in script form.